Greetings and welcome to the Introduction to Astronomy. In this week's exploration of the solar system, we will talk about the PICARD spacecraft and try to better understand how it improved our understanding of our solar system. So let's get started. When you hear the name PICARD, you might picture a starship captain staring out at the stars and saying, "Engage." But this PICARD didn't command a starship, it watched the sun. Instead of boldly going where no one has gone before, and the PICARD spacecraft did something far more difficult. It measured the sun so precisely that even the tiniest changes mattered. This is the story of the PICARD mission and why understanding our star matters just as much as exploring distant worlds. From Earth, sun feels constant. It rises, it sets, and it reliably powers life on our planet. But scientifically, that raises an important question. Is the sun truly constant? Or does it change slowly, subtly, over time? The amount of energy the sun delivers to Earth is called the solar irradiance, and even tiny variations can influence Earth's climate, atmospheric behavior, and long-term environmental trends. To understand Earth, we first have to understand the sun. Launched in 2010 by the French space agency CNES, with support from the European Space Agency, the PICARD spacecraft had a singular focus: measure the sun with unprecedented precision. Unlike probes sent to planets or asteroids, PICARD stayed close to home, orbiting in low Earth orbit. That position allowed it to observe the sun continuously, cross-check measurements with ground-based observatories, calibrate its instruments with extreme accuracy. PICARD focused on three key properties of the sun. First, the total solar irradiance. This is the total energy output reaching Earth. Second, the sun's diameter. It turns out the sun is not a perfectly rigid sphere. It changes size slightly over the solar cycle. Now, the picture shown here is overemphasizing that. The changes are not this large. This is just to show that there are changes, but this is more looking at the distance between the Earth's distance changing, Earth being closer to or farther from the sun. This is not a much larger measurement than PICARD would have found for our sun directly. Third, the sun's shape and edge, called the solar limb. Measuring how light fades near the sun's edge helps refine our models of solar structure. These are changes so small that without space-based instruments like PICARD, they'd be impossible to detect reliably. PICARD confirmed something very remarkable, and that is the sun is extremely stable. Yes, it does change, but within very tight limits. Those precise measurements helped us to improve climate models, reduce uncertainty in long-term solar data, and to separate natural solar variability from human-driven climate effects. In other words, PICARD didn't just tell us about the sun, it helped us better understand the Earth. Captain PICARD once said, "We are explorers." The PICARD spacecraft explored too, not through warp speed or distant galaxies, but through patience, precision, and careful measurement. Because sometimes the most important discoveries aren't found by going farther, but by looking more closely at what's already shining right above us. So that concludes this week's discussion on the PICARD spacecraft. We'll be back again next week to talk about another exploration of the solar system video. So until then, have a great day, everyone, and I will see you in class.